In this presentation, we want to continue talking about graphing exponentials, but now we're going to take a look at how we can actually derive some of the characteristics we've been discussing with the start value, the next point, and the asymptote. And the asymptote is something that we've already discussed because it's that imaginary line that we use with the dotted line that the exponential converges to, never actually touches, but approaches. And we discussed that because that fraction, or that value, actually gets closer and closer and closer to zero as we were applying negative exponents. Now, in our previous presentation, we talked about, hey, what would happen if we have a -2 to the x? So let's go ahead and start off there. And with our first example, let's see what actually happens if we have -2 to the x. I'm going to do so by introducing this concept of a start value. And the start value is exactly what it sounds like. This is where we want to start off deriving our information. And we're going to start off by thinking about what's the easiest exponent to evaluate, and that's an exponent of 0. So in this case, if I put a 0 in for x, it's real nice, that makes that 2 become a 1, but careful, make sure you understand that negative still is outside there because it's not part of the base. So this means we'd have the point 0, -1. Our next point then just means we're going to go ahead and evaluate the next easiest exponent for us, which in this case is going to be an exponent of 1. If I put a 1, that means 2 to the first is 2, which results in a -2. Now that we understand the general shape, this is the only 2 points I need to calculate to figure out what my graph's going to look like or what my sketch is going to look like. But it does help out if I continue to understand what the asymptote is going to be. And the asymptote, again, is going to be at 0 because we know that this exponential is going to actually converge to or approach that 0 value. So y equals 0 is going to be our horizontal line, which is our asymptote. Now if I plot my points, I have 0, -1. I have 1, -2. And even though I only have 2 points, I understand that as I go to the right, I'm going to continue to get bigger and bigger negative numbers. And as I go to the left, I'm going to get smaller and smaller numbers that are going to approach that value of 0. Hence, there's what my graph looks like. Which again, hopefully you're able to make that prediction based off the fact we've discussed that a negative in front of the function basically just reflects the parent function over the x-axis. Now let's go into our next example here. We have a couple more translations actually taking place, but we're still going to do the same thing. Our start value, we want to get an exponent of 0, so that means I'm going to put a -1 in. If I do put a -1 in, 3 to the 0 is 1, which would end up with -3 whenever I go to evaluate this. I next want to use a value that gives me an exponent of 0, or I'm sorry, an exponent of 1. That means I'm going to put 0 in for x. 3 to the first is 3. 3 minus 4 is -1. Now my asymptote in this case, I have to envision the exponential goes to 0. 0 minus 4 is -4. So my asymptote's at y equals -4. I'm going to start off by graphing my y equals -4 asymptote. I plot my other points, 0, -1, -1, -3. And one of the look fors you want to make sure that you have is that both of your points are on the same side as the asymptote. Because if not, that means we would cross over the asymptote and we'd have a bad calculation at that point. All right, so again, what we can see is as we go to the left, we're going to get smaller and approach the asymptote, and as we go to the right, we're going to get larger and approach infinity. Last example. This one has a little bit more going on here because we have 3 times 2, but it's important for us to identify what the base is. The base is only the 2, so keep that in mind. So when we evaluate this, I'm substituting a 1 in for x to give me that 0 exponent. 2 to the 0 is 1. 3 times 1 is 3. 3 plus 2 gives me 5. When I go to evaluate the next point, I'm going to put a value of 2 in. 2 minus 1 is 1. 2 to the first is 2. 3 times 2 is 6, plus 2 gives me 8. Now, this is interesting here because now, keep in mind, the exponential portion's only right here. So that exponential is going to go close to 0 as we get to those negative values that are going to make that super small. So then when I take 3 times 0, that's going to be 0. And then my asymptote is going to be at plus 2. So one of the things you're probably catching on to is the fact that whatever is being added, in this case nothing, or 0, in this case a -4, in this case a +2, that identifies where our asymptote's going to be at. When I go to sketch, I'm going to start off by sketching that line. I can plot my points, 1, 5, oops. And then I have 2, 8. And again, as I go to the left, I approach the asymptote, and as I go to the right, I approach infinity. So there we have a couple more examples with a few more transformations that take place. But things that we still need to discuss: one, domain and range. And then the other thing is, I wonder if we could ever get a graph so that way we would get a shape that looks like this. So that way we'd be approaching the asymptote as we go to the right. But we'll discuss those in further presentations.